Assalamualaikum everyone. I will start by talking about the front end layer, which is a very important part of web application. The front end is the part of a system that users directly interact with. My group number is 4. My teammates Mohammad Bablu and Alamin Ahmed. Let's start. Introduction to the front end layer. We already have known what is front end layer. Interact directly with user. Includes the client, the network path between the client and the data center. Front-end architecture approach. There are two architecture approach. One is traditional multi-page application and another is single-page application. In the traditional architecture, every time a user clicks a link or performs an action, the browser sends a new request to the server. The server then processes the request, generates a new HTML page, and sends it back to the browser. In contrast, single-page application load only one HTML page initially. After that, all interaction happen dynamically using JavaScript without reloading the interface. As you can see in the top half, we have two main components, the client on the left and the server on the right. When a user makes the initial request, the client sends a request to the server processes it and responds it with an HTML page. Now look at the bottom half. This shows the single page application lifecycle. The client makes an initial request to the server and just like before, it receives an HTML page, but this time the page also loads all the JavaScript code needed for the app. Now let's talk about hybrid applications. Hybrid architecture is a combination of MPA and SPA techniques. It means some parts of the website behave like a traditional multi-page application, while other parts works like a single-page application. How it works? The initial page is loaded from the server just like in a multi-page application. Inside that page, certain parts like dashboards, products list are powered by Ajax and JavaScript framework. Going to the next slide.
Assalamu alaikum, sir. I am presenting. I am Alvin Ahmed, and I am presenting what is state and what do we mean by statelessness. Well, to truly understand the architecture of scalable systems, we must first define the concept of state. Simply put, the state of an application refers to any data that the application needs to remember between request or interaction to function correctly. Think of it as the application's short-term and long-term memory. It defines the correct condition of the system. We break state down into two main types: hazard or client state. This is the temporary data stored directly on the user's device, or it can be server state. This is the persistent, crucial data stored on the backend. Managing both types of state correctly is central to creating a reliable and predictable user experience. If state is lost or inconsistent, the application breaks. The two key state management approaches are uh, stateless or stateful. Once we understand what state is, we look at how to manage it, which brings us to two opposing architectural philosophies: stateful or stateless. In a stateless architecture, the server actively saves and maintains the details of the user's session in the local memory. When a user sends a request, the server says, yes, the user is X. I remember they were on step 3 of the checkpoint process, and I have their data right here in my cache. While this might seem convenient, it creates a massive scaling problem because the user's session is physically tied to a specific server. Adding more servers just creates more silos of unique session data, leading to a load balancing complexity and single points of failure. This is why, for modern high availability web servers, we strive for stateless architecture. In this model, the server does not store any session-specific information. Instead, every single request from the client must carry all the necessary information, such as a unique session ID or an authentication token, so the server can process it immediately without relying on previous requests. Stateless analogy. To make the difference clear, let's use the classic restaurant analogy. Imagine a stateful system is like an old school waiter who handles your entire table personally. He remembers you from your previous visits. He remembers your order and he knows exactly where you are in your meal. If that waiter goes on break or gets too busy, nobody else can serve you efficiently because he holds all the state in his memory. Now imagine a stateless system is like a modern fast food kitchen or a highly efficient cafeteria. Every request is an order ticket. That ticket contains every needed order written: hamburger, non-onion, large rice. Any available cook can grab that ticket, fulfill it, and send it out. If a cook goes home, the kitchen keeps operating because the order details, is carried on the ticket itself, not stored in the cook's memory. This is the power of stateless design. Thank you.